Hi, my name is Vaibhav Parshari and today we have Electronics Lab 5 video. In this experiment, we have to analyze and make the circuits of BJT and MOSFET transistors. So this is my ID. Let's just begin with our experiment. In part 1, which is our transistor characteristic experiment, our object is to characterize the behavior of both BJT and the MOS. So first I'm gonna conduct this experiment by BJT. Okay, so at I provide the BCC from channel A to collector of this BJT, which is right there. This is our emitter, which is grounded. This is our base, which I provided a resistor and connected to the pot, and the third pin of this pot is to ground it, and the first pin of this pot is connected to 2.5 volt. So now first I'll check the BVE, which is fixed and it is 0.7. So let's just check the BVE. I'm gonna ground it this, and this is our base. So base voltage is okay. So now our BVE, which is 0.7. Okay, our base current is 0.7, right? So our idea is to measure the BCE and vary the VCE from 0 volt to 5 volt and check the IC. So now I connected this to BC and the BVE and the difference of BVE, and we measure the voltage and current provided through this by changing the voltage from this pixel pulse. So in part 2, which is our BJT driver circuit, our object is to study the behavior of the BJT driver circuit for driving an LED and analyze its performance under varying input conditions. So I provide the 5 volt through this pot, and this resistor is connected to the base, which is our 10k resistor, and through the collector LED is connected, and the in series with resistor, which is our 220 ohm resistor, to the VCC, and our emitter is grounded. So I provided the 5 volt. Let's just provide the 5 volt addalum. Okay, so I provided the 5 volt addalum. I adjust this pot to 0 volt. That our LED is off now. Okay, so just quickly check the voltage. Okay, so it is 0 volt now. I gradually increase the voltage through this pot, and just see in which voltage this LED starts to blink. Okay, so I just started to okay, so the LED starts to blink. Alright, so 0.5, I think 0.6. Okay, so as I increase the voltage, the LED starts glowing brighter, and the voltage is also increasing, as you can see. just increase up to this voltage tends to its maximum value, right? Think it's around. Right, so this is our part 2, which I am just driving an LED by using this pot, and the performance, which I gradually increase the voltage, the LED starts to glow. And the sub part of this part 2, which is measure and record the voltage across collector emitter of the VJT in off and on conditions. So we have to basically find the voltage between collector and emitter at on state and off state of this LED. So let's just check at on state, which is basically 0.167, right? Okay, so at I'm going to increase the voltage as our LED is turned off. Let's just check. Okay, so now our LED is completely turned off, and the measured voltage is 3.517. So yeah, this is our part 2. So now in part 1 we have asked to replace the VJT to this MOS. So now I'm gonna break down the pin connections. The pin 1, or this is our drain. First pin is our gate, second pin our drain, and third is source. So this BCAC feeds to drain, and the output of this pot is connected to gate, and the resistance is 1 kilo ohm, 1 kilo ohm. Our idea is to basically change the VGS through pixel pulse and measure the current. So I connected this pot to ground and the third pin to 2.5 volt. So I'm gonna vary the inputs. First it is around at 1 volt it is around 0.12 and so on. Okay, so in part 4, which is our light dependent resistor controlled LED circuit, I introduce a LDR, which is by using that I'm going to control this LED. So our idea is to blink the light, flashlight to this LDR and see the output of this LED. Okay, so I'm gonna power up this circuit 5 volt. Okay, now I'm going to show the light, and this is approx 0 volt. Just yeah, approx 0 volt. After removing the light, our LED turned on again. So yeah, this is our pretty much experiment of part 4 experiment. Now I'm gonna conclude this experiment. Thank you.